Welcome. In this tutorial we are going to make a simple drawing like a circle or a ball move with PVectors. Right. First of all, we'll need a vector for its position, which is a position is made up of its x and y coordinates, and then we'll need one for its velocity, which is a vector in motion which has direction and magnitude. So we'll also need coordinates for the vector. All right, so let's set up two PVectors. So PVector and then position, semicolon, and PVector velocity. And then we'll need to do the setup method. So void setup, open and close parentheses, open and close curly braces. Let's try that again. Void setup, open and close parentheses, open curly brace, enter, close curly brace. Now in the setup we'll have to set up the size of our world. So size is 300, 300, semicolon. Then we'll color the background white. So say 255, semicolon. And then we'll need to add the original position of the ball. So we'll say position is equal to new PVector, and we'll set it at 50 and 50. So it's basically in the upper right hand corner of our world. So this is called initiation or initialization, when we create an instance of PVector, and this is called assignment because we're assigning the values or the initial values to our position variable. If you forget to do this and you try to run it, you'll get a null pointer exception because there was nothing assigned to the PVector. This basically just creates a position in memory for this data to be stored. Right. And then we need to set its velocity, or its initial velocity, so velocity is equal to new PVector, and we'll want it to move along the x-axis at a fairly slow rate, so let's say 2.4 pixels, and then we'll make it move along the y much more rapidly, so that will be 6. All right, now let's set up the draw method or function. So we say void draw, open and close parentheses, open curly brace, close curly brace. And we are going to say position dot add, and we need to then pass in our velocity. And now we have the initial position, or that if we look at a vector being an arrow going in a particular direction, the initial point of the arrow would be the initial position, and then the velocity would be the direction and magnitude. So it's going, well, it's going in a direction at a certain speed across the x-axis, and it's going north or south along the y-axis at a certain speed. So we have to relate the initial position with the velocity, and that's how we add the two together. And then what we'll go ahead and do is we'll draw our ball, and we'll say stroke weight is equal to 2, and fill is 255 for white, and we'll draw an ellipse. And then we'll pass in, now we need the x and y position of the vector. So we have to call the name of the vector and then its x and y variables. So we'll say position dot x, position dot y, and then the size of the ball, we'll make it a circle by saying it's 48 by 48. We can make it smaller, 12 by 12. And then a semicolon. And you need to make sure you end in a curly brace. So let's run it and see what we have. Alright, so now you see we have a ball and it's falling down the 6. It's being added. So if we change this to a negative, what do you think would happen? If you said the ball will go up, then instead of down, then you are correct. Okay. Now once it gets to the wall, it doesn't do anything, it goes off the screen and that's it. So we want it to bounce on one wall to the other. So we have to add a conditional that says if it reaches the top to come back down or changes directions, or if it reaches the right side, changes direction towards the left. And the same for all 4 sides. So we're going to use a conditional to do that. And so we'll say check if at edge of world. Alright, so then we can say if position dot x is greater than the width of the world, then we want it to go the opposite way. So we say velocity dot x is equal to velocity dot x times -1. And that makes it go the opposite direction. So now we just need to check all of these. So this would be the right edge. And then we can say if position dot x is less than 0, and the same thing happens. Then velocity dot x is equal to velocity dot x times -1, semicolon. And then we need to do the top 2. So we say if position dot y is greater than height of the world, then we'll change the y velocity to be the opposite direction. So we say velocity dot y equal to dot y times -1, semicolon. And then we have one more to do. If position dot y is less than 0, because we're at the top of the world, then velocity dot y is equal to velocity dot y times -1, semicolon. And here I made a spelling mistake. I'll fix that error. It is here 2. Alright, so then let's label these directions so we know. So if that's the right edge, then this must be the left. This must be the top. The last one must be the bottom. Okay, so let's test this out. And now we have our guy bouncing around using vectors. Alright, now if you don't want this tracing, where it leaves the circle after it draws it, there's a little trick we can do. We can draw the background on top of it each time to kind of like refresh it. So up here at the top we're going to say background, and we'll just make it white again. And we'll run it, and you'll see the difference in effect. So now it looks like it's just one bouncing ball. It's creating all of those, but every time it draws the ball, we draw a white background on top of it again. And so it just looks like there's one bouncing ball. Alright, so this is a basic example of using vectors and the PVector class with a bouncing ball. See you next time.